This video is entitled Project Selection and goes along with the book Systems Analysis and Design 7th edition by Dennis Wixom Roth. I'm James Renaud, PhD from Shawnee State University, and I'll be taking you through this video presentation. So how exactly do we select whether to do a project or not? To be or not to be, isn't that the greatest question, or one of them? There are a whole bunch of questions we need to ask ourselves as we decide whether we're going to take on a project. One, the size of the project. That's something we've got to know. How many people, how many man years or man months or man weeks is it going to take, or human weeks is it going to take to do it? How big of a system is it? Is it a little system for a department? Is it a little system for, or is it replacing the entire ERP of a whole business? Big difference. We need to look at the cost. If the cost is uh, right, you get the idea. We just need to understand the cost. We need to ask ourselves, what is the purpose of the system? If the system has no purpose, well, then it would be kind of not real smart to do it. But the purpose of the system can range anywhere from a strategic, to make us somewhere better in the future, to make the business something strategical change. It can be an operational purpose. We need to change operations, and so we need to do this project. It can be a new product we're releasing that's requiring this project. It could be a legal thing. New laws, new legal requirements. There are all kinds of purposes, and often projects will have multiple purposes, but um, purpose. Size, that's another question. Length, I'm sorry, a length. How long is this project going to take? If it's a 15-minute project, if it's a 2-day project, if that's one thing. If it's a multi-year project or multi-project program of projects, then boy, that could be huge. What are the risks involved with the project? And we'll talk about specific risks as we go on. But the bigger and larger and longer the project is, they can be more risky. The scope of the project also kind of relates back to the size of the project, but size, kind of how many people are going to be involved. Scope then would be how much of the business would be affected by this project. Um, how many different departments? ERP replacement is going to change everything, where um, a small project, a small system for a specific purpose might only change a few employees' days. And then, what is the economic value of the project? Is the project going to pay off? We've already asked the question about cost, but what is the payback period? What is the present value or the net present value of the expenditure over the long term, so that we can compare it to other possible solutions? So these are all the factors that we need to keep in mind when we're trying to decide and we're trying to make the project selection question. There are a lot of different methodologies that we may use to actually develop a project. In the previous video, we talked about the systems development lifecycle and the classic waterfall approach to developing to running a project, to managing a project. There are actually a whole bunch of them that I'd like you to know. Um, and the first one is known as parallel development. You can see it right up here, parallel development. And basically what happens in a parallel development system methodology for managing a project is that we take a big project and we break it up into lots of small pieces, and then we run each of those as an individual project. One advantage to that is that the risk of the big project is broken up into a series of smaller projects that we more fully understand. The other thing about parallel development is if the original analysis and project understanding is correct, then when we split it up into its sub projects, each of the teams can run with their sub projects and we can get it done faster. It takes a lot more people, but we can work in parallel. Another model is known as the V model, and this diagram here is kind of a sketch of it. You may also want to look in the book because there's a pretty publisher drawn V model. But basically, with V model, we start with the analysis. And when we create our analysis, while we're doing our analysis, at the same time, we create something called an acceptance plan. As we're doing the analysis, we create an acceptance plan, and basically, that is a report, a document that lists what the system must have, what is acceptable. Makes sense. We're not talking about exactly how to do things. We're not in the acceptance plan. We're talking about what are the things that we must be able to do, not how to do it, just things that must be in this system. Then we go down into the design phase, again, kind of waterfalling down. We go to the design phase, and here we create a unit testing plan, which is the testing the individual programs, testing the individual functions, testing the individual little things in the project. There's a um, the middle plan is the integration plan, where we decide where we have during the design phase figured out how all of these modules, all these units are going to hook together and work together. We call that integration. So we build an integration testing plan during our design phase. And then we build a systems plan, which looks at the entire system cohesively, to see that the system works as we designed it. So the output of the analysis goes into design, and design creates four documents. It creates the design document that we take down to implementation. It creates a unit testing plan, a integration testing plan, and a systems testing plan. So there are actually four things that come out of design. And then we go down into implementation where we actually create the code. Cool. Once we're done implementing, we start our testing. And so we start unit testing, where we take the unit testing plan and all of the units, the programs, the methods, the objects, the subroutines, and all of those things, and we test to make sure that each and every one of them meet the unit plan. Once that happens, we go into the integration testing phase, where we take the integration plan that we developed during design and we test the integration and make sure it all works together. Make sure everything flows the way it's supposed to in the system. Then we take our design document when we created the systems testing plan and we test the entire system. Test all of the way it integrates with other systems, test everything it does, and then we come back up at the very end of the V model development and do an acceptance test. At the very end, we say, okay, we've tested the parts, they look like they work together, the whole thing works together now. Does it actually meet what you wanted it to do? Think about this as like building a car. Implementation phase would be, okay, we built the car. Now, unit testing would be, okay, we test the windshield wipers, they work. We test the turn signals, they work. We test the steering, well, it works. Okay, we integration test, where we make sure that the buttons on the radio hook to the buttons on the steering wheel, hook to all the things that need. So we check all of the integrations between separate subsystems. Then the systems test, we take the car out for a drive and make sure it works and make sure it meets the design criteria. And then at the very end, we do acceptance testing, where it's delivered to the client and the client looks at it and goes, I said I wanted four doors, not two doors. Oops. So there was a breakdown between analysis and design. Hopefully that doesn't happen because the user's seen the acceptance plan and we've looked at it the whole way through. But so the acceptance test would then be there at the very end. So the V model, it's kind of complex, but it's also kind of really cool because as you're going through the waterfall, you're creating these four different testing plans. There's another methodology for developing systems known as the rapid application design or rapid application development, also abbreviated as RAD, RAD. And basically, what we do is we do a whole series of small waterfalls. So we plan, analyze, design, implement, and we get version one, and then we go right back up and plan, design, implement, analyze, analyze, design, implement version two, and then we analyze, design, implement version three. Now, the plan was made at the very beginning of this. So we've made a big giant plan and said, this is what we're going to do, and this is going to be in version one, and this is going to be in version two, and this is going to be in version three. But we can rapidly get version one out, get it in the field, and then move on into version two. So it's known as rapid application design, RAD. So another methodology, and some of these at the end look a little similar, but they're still different because of how they handle things. This one is known as the systems prototyping methodology, and what we do is we go from plan, but we do analysis, design, and implementation kind of all at the same time. That's why they're all in one box. And what happens is we get a prototype. And then we take that prototype back into analysis, design, and implementation, and we get another prototype. And hopefully, we go through one or two prototypes and then we pop out the final result. For instance, I've seen this systems prototype done in website design, where the first prototype is a website done in Photoshop or done in Illustrator. It's not even a real website. It won't even load to a web server. It's just a pretty graphical design of a system. That way, we can create that within the matter of just a few hours a day. Let the client look at it, let them make a decision, get a lot of feedback from the client, and then feed it back into the analysis, design, and implementation. Um, so that would be a place. But if you notice, I said that the prototype, or at least the first prototype, was done using a graphics tool and not even done using WordPress or HTML or whatever you're going to finally create your web page using. So that would be a quick and dirty systems prototype to get the feedback, and then you redo it until you're ready to actually do it for real, and then you do it for real. There's another type of design methodology, of project operation methodology, that's known as the throwaway methodology. And throwaway is kind of interesting because this is how NASA does it, or this is how NASA sent men to the moon. This is where you're using a totally new technology and you have no idea whether it's going to work or what's going to happen or not. So think about the moon launch. Before we actually sent the first men to the moon, we launched a whole lot of rockets. We launched a rocket and tried a recovery test, and we launched a rocket and we did this test, and we launched a rocket into atmosphere and brought it down, and then we launched a rocket that orbited the moon, and then we brought it down. All and there were several launches to test emergency procedures and failure procedures and safety procedures, and that was all done to try to figure out what we're doing. So in a throwaway methodology, we plan, we analyze. We then go into that analysis, design, and implementation triad together, and we create a prototype. But instead of it being a prototype like the previous prototype, this is a prototype that actually works. We're going to destroy the prototype in the process. So think about the moon launch. So we built a model rocket. Boom. We're going to launch the model rocket. Boom. We learn all kinds of things because we did that launch, and that then feeds back into doing the next prototype. So we build a full-size rocket and launch it. Okay, we learned something. We're going to send a rocket into orbit. Okay, and we learned a whole bunch of stuff. So that goes into the same thing. And finally, when we've done that throwaway prototyping enough and we're done throwing them away, we want to do a real one, we go through and design the system. For instance, the first time I developed a smartphone app, The first time I had a client say, we want an app, what I did was I went and wrote a little game. So I wrote a little prototype so that I learned the technology, and then I um, I wrote a more sophisticated database-driven little test program. So I learned. Did the client actually use any of that code? No. Did the final project use any of that code? No. But I learned a totally new technology that got me to the point that I could actually do it for real and make it work the first time. Um, so, so there's an example of throwaway prototyping, um, a throwaway methodology, and maybe why you would want to do it. The last methodology that I want to talk about is the agile methodologies. And there are a whole lot of different methodologies that are all lumped into being agile. For instance, extreme programming, Scrum, and lots of others. There are lots of different agile methodologies, but they all kind of have a diagram or a kind of a flow that looks like this. Basically, we start with a plan, and then we get together and analyze, design, and implement a little system. So we implement, and it's not just version 1, it's version 0.1, and then we do 0.2, and then we do 0.3, and we do 0.4. But the thing about these are they're usually set to a sprint. They're usually set to, instead of we're going to get all of these features for the first version, no, we're going to spend 2 weeks. And what we have at the end of 2 weeks is the first version. And then what we have at the end of the fourth week or 2 weeks later would be the next version. And then what we have 2 weeks later would be the next version. So these are done usually in things we call sprints, which are time based instead of being feature based loops. They're time based loops. A lot of this is done face to face, where the design and the analysis are all done on the fly in these short sprints face to face. It's a very agile method for developing software. But you don't create all of the documentation throughout. You create it as you go, and it takes a lot of communication to be able to create. Well, it takes a lot of communication to pull off any of these methodologies. How do you choose? How do you choose how to approach a project? Well, this chart is kind of a good start to look at it, and you'll find this in your book. If you have unclear user requirements, if the user can't tell you what they want yet, then waterfall and parallel and V-model probably aren't going to be very good methodologies because you need to you need to do all that in the front. Where a systems prototype or a throwaway prototype or an agile development would probably work a lot better for you. If we had oh, excuse me, if we had unfamiliar technology, if we didn't know what the technology was going to be, then the waterfall, the V model, and the parallel would be very poor. Systems prototyping would be poor also because we couldn't prototype a system. But a throwaway prototype would probably work better for you with an unfamiliar technology. Projects that are extremely complex, like a moon launch, well, that would be a great thing to do throwaway prototyping. Um, for a very complex system to do the waterfall, to do the analysis, and to go parallel, to do the V model or the iterative model might also be very good ways to handle it. If we need ultimate reliability in our project. Well, the V model does better for that because it creates all these testing plans and acceptance plans that we're always checking back to. Also, the throwaway prototyping is usually really good for reliable systems and agile development. Really, most of them are good for that. When you've got a really short time schedule, when you've got a really, really short time schedule, the iterative and systems and agile methodologies can get that first version out there and get that next little first version, the second version, and the third version. So that's a really great way to handle it. And schedule visibility is where they want to see what the schedule is, and you're sticking to the schedule. You've got certain features that are due by certain dates. Well, um, the waterfall, parallel, and V model are a little bit less good for that because you've front loaded a lot of work, where the iterative and systems prototyping are often best for that. So when you look at your system criteria, you look at what the reasons for doing the system, you think of the various methodologies and ask yourself these questions. One of these methodologies will probably fit better than any of the others. This concludes video 2A for the Systems Analysis and Design course. This video is copyright 2020 by James M. Renault, PhD, except for the chart on slide 7, which was from Systems Analysis and Design 7th edition by Dennis Wixom Roth, published by Wiley. I'd like to say thank you for watching, and I hope to see you in another video soon.